that very well. But we have so anyway, it's open source tools for environmental sensing. Dr. Peter Marchetto is here, and we welcome you. And
I'll get you with the highlighting parts.
I'll give a little better introduction of Pete Marchetto. Is research engineer and instrumentation scientist on staff at FieldKit and Conservify. Right?
Conservify, yeah. It's an awkward name sometimes.
What is it?
Conservify.
Conservify, where he's responsible for calibration, sensor selection, and evaluation, among other system testing and design tasks. Previously, he was an assistant professor at the University of Minnesota's Bioproducts and Biosystems. Okay.
You can skip that, and I'll just give you the lowdown really quick.
Go ahead.
I'm
right.
Thank you. Sensor guy who's come down here from Cornell to tell you what you're doing wrong. I'm kidding. I'm kidding. I'm Pete Marchetto, and basically, I build stuff that wildlife and nature tries to destroy while trying to get relevant data from interested parties. I build things that go outside and listen to the natural world through microphones, through pH probes, like one that I've got here today, and through conductivity measurement devices. Basically, if you have a parameter you want to sense in the natural world, like for example, I heard you guys talking about view sheds. If you want to calculate what a view shed looks like, or what exactly the light levels in that view shed are, or anything like that, solar radiometry suddenly becomes an issue for you. And that's where I come in as a sensor specialist. So open source basically means we're going to tell you, whoever you are, how to build the thing that we build too, in case you want to do it with your own resources and you don't want to have to buy it from us, because we don't want to keep all of this stuff hidden away. There are companies out there, if you're in the National Park Service, or if you're in the TCNR, or if you're at the state level in New York, you're probably familiar with names like Onset, Campbell Scientific, etc. All of these guys, the guys who make you pay through the nose for getting data. No offense, especially to those of you who may be seeing this and it's recorded. But the thing is that what we're trying to do is make it so that we can bring the cost down and still get just the same quality of data out, so that you can have more coverage over a larger area. Anyway, open source tools just means that we give you the direction, build it yourself if you want to. Environmental sensing, that's the writ large part that I just went through. Any sort of thing you want to know about the natural world, that's part of environmental sensing. We don't do them all yet. The part of being open source is that we give you the information and the tools, or somebody who you may either fund or work with the tools and the information to then figure out how to find that particular environmental parameter and record it, so that you have some idea what's going on, what interference is being made by humanity in the natural world, or what phenomena are going on in the natural world that you want to study. So, and I'm guessing I may have to beep at you instead anyway. Huh. All right, so Conservify and FieldKit. Conservify is a project of Multiplier. Multiplier is basically like, have you ever heard of a business incubator? Basically, it's a business that has other businesses growing within it, like metastatic tumors. No, maybe not that. Maybe more like a fetus, okay? But Conservify is a project of Multiplier, which is a large business incubator, but specifically for not-for-profits. And Conservify is actually a makerspace, a hackerspace, however you want to call it. It's basically a workshop that sits on Broadway in Los Angeles and is a place where anybody who wants to measure something in the natural environment can go and get help building that thing for low cost. FieldKit is a project that came out of Conservify when the founder of Conservify, or founders of Conservify, realized, you know what? Maybe we should give people some tools to really get started, because everybody who's coming to the makerspace, there's a lot of commonality between what they want. They want something to log the data that they're getting. They want some sort of basic set of sensors that almost everybody who's doing like water quality, or everybody who's doing weather, wants the same stuff. Okay, so maybe we can give them a head start by starting out with a kit that goes in the field. Maybe we'll call it FieldKit. So what is FieldKit? It's open environmental sensing for everyone with fun pictures. But really, it just means that it's a way of, it's a device that allows you to figure out things about the world around you. And in the way that it does that, you're basically just recording sensor values. But it's a little bit more than that. It's open source tools, meaning that these are tools that we give you the key to. You can find out all of what's running under the hood. You can read every last bit of our code. None of this is closed or proprietary. Anybody can replicate the whole thing we built from the ground up. We're a 501c3, and we really don't care because we're not operating for profit. We're selling this stuff and just making back our money. It's a platform for learning and sharing, meaning that it is a platform that both has an online community. If our community manager, Lindsay, who's usually in on calls that I'm giving talks at, is watching, hi, Lindsay, she's going to love me saying that we have an online platform where you can go on and ask questions of other users and say, I need to figure this out, and nobody's got a solution for it. And then you have a whole bunch of people who you can work with on that. And you can also share all of the data that you want, or let's say that you're an academic like I used to be, and you have to embargo your data because for another 2 years, you're still in the process of trying to get that frigging paper published. You can also hide your data from the rest of the world for a given amount of time and then go public eventually. And it's a community of environmental care. It's a way of trying to bring together a bunch of people who want to sense things about the natural world and make a difference in making them better. So the way that this works, there's kind of a spectrum. There's home-built open source products. There's consumer grade, what are known as IoT, Internet of Things. Any of you who were talking during the first meeting in here about like satellite connected cell phones and such, that's kind of the edge of the current bleeding edge of the Internet of Things, as we call it. And then there are quote unquote proven scientific tools and custom built one-off scientific equipment from various instrument makers. In a way, that and this are the same thing. It's just who's doing it, whether it's the scientist who's trying to gather the data or whether it's the instrumentation engineers who you're paying the big bucks to. FieldKit sits in the middle between these, and we're trying to go towards this. So the things we're making are a web portal, a back end where you can view your data and others' data that's freely available. The app itself, which you use on your phone to download data from one of these boxes that's out in the field, and the FieldKit hardware, which, well, this unit is outfitted with 4 pH modules inside of it so that I can test different pH probe brands and see whether or not they work with our hardware, for example. But it's that simple. I can reconfigure all 4 of those to be anything from a weather station to pH to electrical conductivity. We've got turbidity coming down the pipe, water or soil temperature, you name it. You can just snap the little circuit board in, connect up your sensor to it, and away you go. You're off to the races. You run up to this thing, put our app on your phone, click a button, downloads data from the last week, month, year, whatever. Meanwhile, this thing's running off a solar panel. I'll show you a picture in a little bit, one that I've literally got in my, I wouldn't say my backyard because I live over in Forestburg, and so I've kind of got forest all around me, so everything's my backyard, but I'll show you that in a moment. Some of the hardware we've got includes weather stations. These are relatively inexpensive, but we found them to be surprisingly durable. We also do distance detection. Might be useful on the Delaware River. I'll get to why in a moment. Weather sensors, temperature sensors, like I said, you name it. We've got various different ion selective electrodes. So we're also starting to look at nitrate as a thing that we can sense. Really great for if you happen to have, septic system leaks, or no offense to my friends here from Pennsylvania, but if you have a whole bunch of places with turkey pits that happen to be more than like 20 years old, and they happen to be upstream of a confluence that you're worried about, like a trout stream. Just saying. So yeah, you can customize whatever combination you want. And we've got an interesting sub-story here. I'll try not to take too long on it. We were evaluating these modules from another company that said, we're going to make these things that will make it easy for you to make water quality measurements, pH, oxidation reduction potential, dissolved oxygen. If anybody does any trout fishing, you know exactly why I'm interested in that, water temperature. And they weren't cutting the mustard. So we wound up rolling our own and then presenting about them at the American Geophysical Union last year. So we have an international scientific conference that we've presented our circuit designs at. And the earth scientists there were like, can we copy this? And I'm like, it's open source, so of course. And right now we're in the midst of blowing this thing up and putting it in the water as well. So we're going to try for probably around 100 meters at first of submersion. And obviously at some point, once I have one of these underwater units fully built up, I'm going to see if somebody will let me throw it into the Narrows in Narrowsburg. But in the meantime, I'm trying to get permission to go into a couple of lakes in Sullivan County that are a little bit deeper. So anyway, the app is relatively simple. It's a matter of rolling up to the sensor or walking up to the sensing system, pressing a button on the outside. It shows up as a little wireless network on your phone. You click on that, you open up our app, and it says, okay, I've got 5,223 measurements. Do you want to download them? Oh, of course I want to download them. And then I walk back out to my car. I'm now back on the cellular network. It says, do you want to upload these to our server? Of course I do. Okay, click the button for that. And then I come back and I see this nice graph at home once I'm done. So yeah, there's a lot of information that we also take down. We automatically generate the maps. We ask for, when you're deploying the station, for you to take pictures of it so that you have some documentation. We ask all the leading questions that you normally need for like citizen scientists to define, oh, well, this study is to do this. This is why I'm choosing this particular location, blah, 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 blah. But we ask leading questions in the app to actually get people to report that data so that if you as a professional want to then go and see the data on our website, you're like, oh, this actually has some sort of scientific reasoning behind why it's there. And, oh, thanks, well, that's thanks to the leading questions we asked the user. Portal, the data portal allows for us to kind of scrub backwards and forwards in time and read out individual parameters and then add them up into a nice big screen. We also, because we are who we are, we acknowledge what lands we're sitting on insofar as who was here first. Like, for example, on my portal page, it says Muncie Lenape land, just, you know, because it's nice to acknowledge that sometimes. And then we have a massive product guide that tells you not only what this is and how to do things with it, but how to use it, how to replicate it, basically, if you want to. And we do a lot of these. Oh, look, there's me. I did this lecture for one of our little programs online, got recorded as a YouTube video as well, literally called How Can I Trust Anything? Part of my background is as a calibration technician. So I don't trust measurements unless I see an uncertainty next to them, and then a whole chain of documents going back to the National Institute of Standards and Technology, and also I'm going to screw this up, but Bureau Walls et Mets International in Paris, France. So that's how I got my PhD, was running down things like that. And so I give little lectures and things like that so that other people can get these general concepts and see how they're relevant to environmental sensing. So who is FieldKit? Just to give you a rundown of who this crazy cast of characters is. Sean Selby is our fearless leader and co-founder and executive director. And his background is originally as an aerospace engineer with Boeing. And then he basically thought, you know, maybe I want to use my engineering skills for good rather than for military purposes. So there's a whole lot of people out there who need tools to determine things about the natural world. Maybe I should help them. Jared Thorpe refers to himself sometimes as our creative director and also as a data scientist. He's at NYU as a professor in basically data visualization. So he's the one who's behind a lot of the appearance of our portal and our other stuff. Jacob Brown is our principal engineer, who's now, actually, Jacob runs software and firmware. Everything that has a programming language associated with it, this man does. Susan is the one who makes it all roll. Bradley is the one who has the Mohawk and the electronics experience. I'm the one who has the electronics experience and no Mohawk, just so that we're clear. Sarah is the one who breaks things on purpose. And Lindsay is our community manager who makes certain that we're able to talk to people. So some of the projects we've been involved with, we have one currently going with the WCS, Wildlife Conservation Society, Citizen Science for the Amazon. We're working with some folks from, I think it's the University of Miami in Florida, doing various different deployments in the Amazon right now with these sorts of packages and looking at water quality in various different fisheries contexts within the Amazon. We also have a program going on funded by NSF that's joint with the UCLA Institute of the Environment and Sustainability that's in Cameroon, where we're actually implementing kind of, shall we say, bush or jungle measurements that have never been made before. And we're actually making data measurements out there for a number of different weather parameters in the midst of a rainforest that has never really been gauged. We've never really seen weather data close to the ground inside of a rainforest or up in the very top of a tree. Jacob and Shad have both been actually training with an arborist down in California so that they can go and deploy weather stations on the top of the canopy out there in Cameroon this coming year. So then we also have something a little bit more local. If you've ever heard of FloodNet, it's a New York City it's a New York City DPW, NYU, and CUNY project that we also happen to be involved in making the data portal for, based on the data portal we made for FieldKit. And it's literally a bunch of distance sensors that then tell the city of New York, you have flooding on this block and this block and this block. DPW should shut down those roads, get the pumps out. People are going to need their basements pumped in this particular area, and is way more efficient than trying to get reporting from the individuals who live in those areas. It's also slightly, shall we say, preventative, because there have been people who literally drowned in illegal basement apartments in some of these neighborhoods. So trying to save them from that. Some local emplacements. So over where I live in Forestburg, I have a depth sensor above Black Brook. Black Brook is a tributary into the Mongaw. And so I have both temperature and electrical conductivity there, as well as the depth sensor. And then I've got a weather station on top of this mast. The mast itself is just a piece of 2-inch electrical conduit on top of a fence post with 3 guide wires. And it has withstood, it's withstood 2 remnants of tropical storms now, and a number of trees falling on it thanks to my contractor. And then we also have an affiliation through the fact that I was a Homestead kid in Glens Bay with the Comstocks. We have a station on Tuttle Creek there, also a tributary into the Delaware, over there near Pondetti, in Glens Bay. So we've been measuring stage height for them as well, and we've got a weather station there. We're doing conductivity, and then we also have solar radiometry, which is kind of an experimental thing for us still, but it's something that's very useful in the future. As soon as we get the rough edges knocked off the design, we'll start rolling that out. But the nice thing is that we have a test station that's pretty close by for that. So how's it useful? Some recommendations that I might make to somebody who wanted to use a field kit or a system of field kits on the Delaware River. You've probably seen this in Berryman. Well, what if you wanted to remotely gauge this? We have long-range radio transmitter capabilities as one of our modules that we can put into this thing. So if you put a distance sensor at the middle of the Shohola Berryville Bridge and it's downward pointing, now all of a sudden all the rafting companies know, without sending somebody over here, it's not just landers anymore, because I think they're the ones who actually have that launch site down there, if I'm correct. Sorry?
Reaper has it.
Oh, it is? Okay. So it's not just them anymore who can just like roll up to this thing and say, oh, no, this is our private property, etc. Now, all of a sudden, every one of the rafting companies knows exactly what the gauge says there remotely, as do all the private individuals who want to see whether or not the staircase is going to be a class 1 or a class 2 as they take their kayak down the river. Some other things, you may recognize this map, although it's a little sideways right now. This is, each one of these blue things is a proposed field kit site. If somebody were to do stage gauging along the entire Delaware, each one of those would be at one of the interstate bridge crossings, whether it be a road bridge or whether it be a railroad bridge. another thing that you could do is ask questions. No, wait. This one shifts a little bit. This is a one that was suggested by my friend Steve Shaw, who's he's a hydrology professor up at SUNY ESF up in Syracuse. Steve and I were talking when I was up visiting with him, visiting one of our co-deployment field sites up at Hammond Hill State Park just a couple of days ago. And Steve was like, I'm doing this cool thing where I put in a pulse of salt upstream, and I measured stage height there and stage height downstream, and I measured the conductivity in both places and how long it takes for that pulse to get down there. And I don't have to go across the entire stream or river that I'm gauging and get the entire stage discharge curve. Instead, I can just look at how dilute that pulse of salt has gotten downstream, and now I know from just what the height is and that dilution what the flow rate is. I said, well, could you do that with a bunch of confluences? He said, oh yeah, you could easily do that. That's basically what I'm aiming for, is doing that in a river system. That's what these are. This is every single confluence along the same stretch of the Delaware. So not telling you guys what to do, not telling anybody that this is a great idea. I'm just saying that hypothetically, if somebody wanted to measure discharge from the various different tributaries into the Delaware, this is the sort of map that you'd follow to do it. And there's plenty of other different sorts of patterns that you can follow to measure various different variables. Anyway, with that, I'll stop yammering at you and giving you my version of kind of a sales pitch, and instead ask, are there any questions?
Well, one thing I'd like to bring up was what you just addressed here.
Yes.
Because there's been quite a controversy over the years of flow. How much the flow is, how many cubic feet, so forth.
And the thing is that insofar as stage discharge curves, figuring out what that height is versus what the width is with a dynamic riverbed like the Delaware has is difficult.
And
Maybe that's an understatement.
sometimes there was a problem because it could be raining like crazy down here.
Yep.
And they would adjust the flow out of the dam, and upstate was not having that kind of rain thing or anything. And there was a problem.
Yep.
Because they worried about the fishery too.
Yep.
And it certainly makes a tremendous amount of sense. And something like this could be applied up and down the river and use that data to control these things, or at least say, hey, we should do this. We should let the flow come now or not let it come now or whatever.
Predictive flow management.
Besides that, the thing of tremendous storms that we have in floods.
Mm-hmm.
So this is quite interesting to me. I think this is really something that needs to be further investigated.
Wouldn't it be something that the river master more than
us? Yes. Yeah, absolutely.
Hey, what about the USGS? When I want to know what the flow is on Lackawaxen or on the Mongoff or any of my, just go to my USGS site.
Yep. But the thing is that
And it has oxygen.
Yep.
Temperature.
yeah, a lot of them in Delaware are
Ready.
luckily the enhanced gauging stations.
Yeah.
So you do have that working for you. The thing though that I would point out is twofold. Number one, over the course of my career, I've seen the USGS gauge population shrink. That's something that has come from a couple of different places. Not to go political on this, but over the last couple of administrations, there have been a number of pieces of legislation put forth that dictate that unless there is a very specific monitoring program going on within the USGS, that there must be local partners or NWS partners given to a particular USGS gauging station before USGS will even go out and survey the point of installation, much less than trying to figure out whether or not there's a proper stage discharge curve for a non-channelized flow on something like a loose bed river, if you will, like the Delaware or the Lackawaxen or any of the others. So the other thing is that when it comes to the Delaware and its tributaries, then USGS is great at the Delaware and USGS is great at the intersection of the tributaries with the Delaware. Going further upstream, though, you may not exactly have the same coverage unless you're in like the Mongoff, where you have dams further up the same river. If you're in any of the creeks, then you're usually in like a second or third order stream, and USGS usually doesn't I wouldn't say they don't bother putting things there, but they can't necessarily afford to put gauging stations on those. So the question that we often wind up asking ourselves is, can we fill in the gaps in between USGS gauging stations? And I think the answer is yes, and we can do it for a reasonable price.
Yeah, that was gonna be my next question, Peter, the all $90, right? You know, these gauging stations can be pretty costly, you know,
Yeah.
New York State, we have to kind of pick and choose where we want these things.
Well, USGS, I think it's something around somewhere between 10 and 15,000 for just the base unit from YSI, and then the calibration protocol that's dictated. I think they have to ship them down to Louisiana still, which then between that and the hours involved usually nets you about, I think it's around $5,000 for the calibration annually. The on-site work also adds another 15 to I think 25,000, depending on whether you're doing a channelized or a non-channelized flow, and whether or not you have to create a stage discharge graph, which once again with loose bed creeks and streams like we have here, it's kind of a fool's errand to try and create a known stage discharge curve that's going to be set in stone. No pun intended, because you go a little bit further north and something like the flatbed rivers of like Broome County. Now all of a sudden you have these big flat sheets of bluestone that are underneath, and you basically have a known dimension flow, whereas we've got gravel moving all over the place in the Delaware. So insofar as our stuff, we aim to make every station that goes out there under $1,000. And we also do internal calibration of every parameter that we can manage, and we're currently growing that catalog as well, all to NIST traceable standards. And then on top of that, we're in the process of doing A2LA accreditation so that all of these will now be ISO 9000/ISO 17025 compliant, meaning that aside from the fact that, no offense meant to the state of New York, but we still have to develop a QAP for these things to actually get usable numbers from a legal perspective. Other than that, everything would stand up as chain of custody compliant, and insofar as, well, the calibration standard for ISO 17025 is the same one used in hospitals. So the same chain of traceability, the same chain of uncertainties as they would use in the medical profession.
In remote areas, are you able to send the data through satellite?
Not yet. We have been actually talking about using the Stinger 1, which is the Global Star module that is the precursor to the one they're working on with Apple. I heard you talking about that before. And I was mentioning to Lori that I've been an amateur radio operator since I was 13 years old. I'm not actually convinced that satellite is the best way to go, especially if you're in the middle of a mixed hemlock rhododendron forest, because the wavelength you're operating at, or the frequency, which is usually in like the 2 to 5 gigahertz range, you get a lot of screening from forest. However, horizontal transmission at lower frequencies, like those used in LoRaWAN and such, 433 megahertz if you have a license for it, or 915 if you're just using the ISM band version without a license, those you can get like 14 kilometers away, so several miles away between transmitter and receiver, and that will cut right through vegetation. So without having a large tower, which would be diffusion, as it just a little thing I picked up in that other meeting, right?
Those frequencies aren't typical of cell phones. That's the
Right. That's the reason for that is because the ISM band is specifically unlicensed. So 915 megahertz is the unlicensed portion. There's also some unlicensed frequencies we've been playing around with in the 150 megahertz range, the MERS frequencies, where you can push up to 2 watts, meaning that you could get up to like 30, 40 miles from point to point. We're not there yet. This is all just speculative at this point, but right now, LoRa, which is 915 megahertz, that's something we already have implemented. We don't have it on like one of these things, but we do have a module you can install for that. Otherwise, it's still a matter of maybe we get a citizen science program together where we involve the public, and everybody who goes out there with a cell phone downloads the FieldKit app, says, oh, okay, I'm next to one of these things. I push the button, click the button on my phone, and I've got data. Next time I've got cell service, upload it. And then the thing is that our portal sorts it out by what the station number is, the unique identifier. So anybody literally can download the data and then upload it later. So, just a public involvement.
Yeah, Lori?
What were the dimensions of that underwater unit that you had? It was hard to tell.
Oh,
I don't know how big
We're
that
going
is.
about 24 inches long maximum, and we're using, well, the interior diameter is about 4 inches, so the outer diameter for the whole thing is about 6 inches.
I was wondering how that compares. I know Don Hamilton's here on the data songs that the Park Service uses.
Yeah, I was wondering, I
Is that
think
the
those are
same,
what,
or-
the was that the XO1 from YSI or something like that? Those are usually, I think, about 4 to 6 inches in diameter as well, and probably about 2 to 3 feet. But that's without the logger on board. The logger, I believe, is still separate for the YSI with songs.
And you just lower it over a bridge or over a riverbank and.
Well, with
let
ours,
it sit
you just
there?
leave it in there and the data logging is on board. You basically anchor the thing, chuck it overboard. Actually, we literally are designing it for marine applications where you're literally on the deck of a ship and you have to throw it 50 feet down. So you could throw this off a bridge, and as long as there's enough water underneath it, it would just sink to the bottom. Then you've got to fish it out later, though, of course. So maybe you want to try and do it by a pier so that you can get a boat up next to it. But that's kind of our general direction for the riverine and limnological perspective.
Are you using ultrasound for measuring?
Distance, yes. We've been talking about maybe doing optical as well, just because of the fact that ultrasound has a couple of limitations, especially the Delaware, where you do develop ice sheets during the winter. That could be a little bit of an issue. The other thing is that the ultrasound is highly temperature dependent, both at where the ultrasonic sensor is, and then you're going through, like, you know how fog likes to collect at the bottom of the valley. That means that you have a temperature inversion already. So now you've got essentially a stretching of the acoustic pulse to go through that at a different speed of sound. Then it gets down to the water, then it reflects, get another stretch. So you have to adapt for that somehow. And usually we'd have to somehow dangle a temperature sensor along with that if you're doing a really, really long cast. That being said, if we're talking about summer during the middle of rafting season, I don't think you're going to be getting nearly as much fog inversion and nearly as much distortion of the measurement. But optical would allow us to actually forgo that completely, because the having any sort of problem with obscuring of the water surface within the wavelength we're working in, we'd probably be working in the infrared, so fog wouldn't be as big of a deal for us. We should be able to still see the water surface.
Changes. Don't you have to calibrate for varying temperatures?
Well, the thing is that we'd have the calibration done ahead of time, and we'd have the temperature sensor out. So now you've got 2 inputs, 1 equation, 1 output. That output is distance.
So you're always monitoring temperature and adjusting.
Correct. Yep. It's a hard question, and it's one that we've been working on actually presently. And I'd say we, but I'm the one doing the math.
Not to oversimplify, trail counters?
So I keep getting questions about trail cameras and acoustic recorders. And there are open source projects on both sides of us that work on both of those things. And we're trying not to step on toes, but at the same time, we are talking about integrations where, if nothing else, we can have a wire running in here saying, oh, I just took a picture, and then you can correlate that with logging. So that's one thing we're looking at. And then also the Audio Moth is the open source acoustic recorder that we've got I'm trying to remember on trail cam. I think it's literally called Open Trail Cam, but I'm not certain. Once again, it's a matter of just kind of having a signal that would synchronize the two things and say, oh, an event occurred. Right now, we're not necessarily looking at like recording audio on board. It would take way too much power and way too much processing capability for what we have on board right now. But we're aware of projects similar to us that could fit those areas.
A lot of our like state sites and partner sites just simply have just a reflective beam.
Oh, you're talking about
Literally just a trail camera. Just how many times something passes.
right. And the other thing is that insofar as what we were talking about before with like stage discharge. So the lab that I worked at Cornell, my boss at the time, Todd Walter, was working on this method where you could actually use a trail camera that was set to take a picture every 10 minutes to actually gauge the amount of water coming out of a storm drain. So there is also the use of trail cams in that way to actually get discharge rates from tributaries or from storm drain systems increased. But insofar as what you're talking about with number of people or number of animals passing, doing like a photo gate system is actually one of the things that we've been requested by a number of different potential customers. So it's on the list of potential sensor developments. And actually at the beginning of November, I'm out in Los Angeles, their headquarters. First time I'm ever going there. That's the nice thing. I get to live up here and work remotely for these guys. So I get to go out there now and tell them, all right, let's re-examine our sensor priority list and see where exactly we're going to set everything at. What's our order of operations? And if you're saying that knowing how many people are going down a trail is a priority for DCNR, I would agree with you, because it's also probably a priority for New York DEC, and NPS might also want some of that action, just saying.
Do you say that nitrogen being able to like detect that is, you can do that?
It's
or
in
you
the
work it?
cards. We don't have it. We don't have something that we're selling for it right now, but the pH modules that we've been working so hard on can read any ion selective electrode, nitrate, phosphate, iron. One of the things that we've been talking about internally is what the full complement would be of ion selective electrodes, so that we could get every sort of heavy metal and every sort of organic cation or anion as well. And so we're currently working towards, from like a drinkable water, a potable water perspective and a water source perspective, we're currently working towards creating a complement of those ISEs that would allow us to basically monitor water quality on the input side rather than just the output side for toxins. We'll see how it goes. Anyway,
I think we're gonna wrap it up.
thank you for all the questions.
Yeah.
Incredibly insightful.
Very good. Okay. Yeah, Don Hamilton, he's our measurer in chief. He measures things like mussels, mussels
Yep.
in the stream beds, and shed runs and things like that. I didn't hear much about these living natural creatures.
There's some amount of work I know where some people have instrumented mussels to actually like close a switch if they close up as a toxic plume or any sort of plume of some sort of chemical they don't like passes by. And it's something we've talked to a couple of people about, but once again, living sensors or biosensors, that's probably still complementary to, not inclusive in our plans right now. That being
We'll keep
said,
Don for a while.
yeah, I was gonna say, Don, if you're hearing this, I'm gonna leave a card here for you, okay?
Okay, and we'd like to present with you with our Delaware pin, and you put it, your colleagues at home will be very jealous. But,
Yeah, I'll wear it to Los Angeles. Thank you so much.
Serves as an electrode.
Sorry?
It doubles up as an electrode.
Yeah, but only one. I don't know where the other half is.
We only give you cathodes.
Dang it. I want an anode. Or can I leave this with you for
Yes,
Don there?
please do.
Yeah.
And-
yeah, we'll just-
Although he's retiring soon, so,
yeah, yeah, give that to us.
sure. Thank you.
Thank you.
Okay.
It's the first regulatory agency. You guys kind of have the whole thing covered. Thanks a lot. I guess I need to give you guys one too.
Yeah.
That was a lot of stuff.
All right.
Now, this is kind of left me out of the store.
What'd you think, Harold?
Well, I thought that, I was gonna ask you if you knew anything about dodecaponics. So I could feel good about what I'm talking about.
Now we're gonna get on to the more complex stuff, like, can we approve the minutes of our last meeting? That was moved, September 1st minutes by Harold. Second, please. You get a second to approve the minutes, Al? Any discussion, all in favor? Aye. Any opposed?